Example 4, in the picture, it gives us a graph of 1 over x squared. I don't know if you remember drawing that in grade 11, called like the volcano graph. Yeah. So describe how that graph of 1 over x squared could have been translated to create the graph of each function below. Okay, so the first thing in here that I'm going to underline is the word describe. In grade 12 pre-calculus, they have command words that they expect you to know. In fact, they even give them to you on the formula sheet on your exam. If you see the word describe, you have to use words to describe it. If you just draw math, they're going to give you no marks. They have that for 2 words, describe and explain. The explain one's worse. Sometimes students just do the math, and when the exam is marked, they're told if it's an explain question and the student has done math, you're supposed to cover the math with your hand and just read their words. And if their words make no sense when they're on their own, you have to give them 0, even if their math is right. So describe and explain means that we have to use words. Now in this one, it's really obvious that it would be words that you would use. For A, you want to describe how it could have been translated. What are the equations of the asymptotes for each image graph? So in A, the first thing I'm going to do is I'm going to rewrite this with the 3 on the other side. And then I'm going to ask myself, okay, is that 3 inside the function or outside the function? This one's outside the function. It's going to move it 3 units up. Proper words, it will be translated three units up. On our original graph, I'll draw them in with a red dotted line here anyways. Our original asymptotes are at x equals 0 and y equals 0. In A, if you translated that 3 units up, can you see that your asymptotes would still be x equals 0, but your horizontal one, if you moved it up 3 units, would now be at y equals 3. Okay. Everything that's outside the function is exactly how you would think it. Inside the function's where it's the opposite. So if it was here, you see this x plus 3 on the bottom of the function, that's going to move it 3 to the left. But everything that's outside of the function, this plus 3, moves it exactly as you would think, up 3. But that's an easy thing to get mixed up in this first unit, is which one switches and which one stays the same. Anything that's inside the function, those are the ones that are going to switch.
I thought just like when you're looking for the asymptotes, like you make y equal to 0 and then you just subtract.
Oh, if you make y equal to 0, what you would be solving for is an x-intercept. So in this case, it's much easier. Just think, if I moved this graph up 3 units, where would it go? Right? If I moved everything up 3 units, well, oops. What would happen to this dotted line? It'd move up to there. So in part B, again, I'm going to rewrite this with the y by itself. So that would mean I would subtract 4 on both sides. Well, we have a 3 inside the function and a minus 4 outside of the function. So describing it in words, it will be translated. The 3 inside would be 3 units to the left, and the minus 4 outside would be 4 units down. If we think about our asymptotes, can you see that if you moved it 3 units left, that vertical asymptote at x equals 0 would now be at x equals negative 3. And if you moved it 4 units down, you would be at y equals negative 4.
That's like it cannot do that, right?
Right. The graph never touches that, But when we write an equation is always an equal sign. So if you're talking about a non-permissible value, so in this case, x, if I wanted to say, what's my non-permissible value? X can't equal -3. That's where I would put the line through the equal sign, because I'm talking about a non-permissible value. But when we're talking about an asymptote is an equation. That's the equation of that line. So when we write an equation of a line, it's always an equal sign. That's a really good question, because it is very tempting to put a line through those asymptotes. And they would take off a half a mark on your final exam for that as a mistake, because it's not an equation anymore then, because you've crossed out the line, the equal sign. Okay, 16 and 17.